This video is to accompany the Lehmann's Intermediate Algebra textbook that is used at Kenyatta College, and I'm talking about sections 9.1 and 9.2, graphing quadratic functions in both the vertex form and the standard form. So I'm going to start by going over the example that I was covering in my classroom. I had already talked about the fact that a quadratic equation or a quadratic function, which is also called a second degree function, has a type of graph called a parabola. And we know that this is the type of graph we are dealing with when we have either the quadratic in standard form, this form right here, which looks like y is equal to ax squared plus bx plus c, or when we have it in what is called the vertex form, y is equal to a times x minus h quantity squared plus k. When we're looking at these two forms, they both have a in them. This one here at the numeric coefficient of the x squared, and this one here as the numeric coefficient of the parenthesis value that contains the x, and that quantity being squared. In either case, if the a is a positive number, we know that our parabola is going to face upward. And recall that a parabola looks like this here if it's facing up, and if the a is negative, it's going to face down like this. So happy face versus sad face for those a's. The vertex of a parabola, and a vertex of a parabola is where it's at its lowest or at its highest point, depending upon if it opens up or down. That vertex in the standard form, the y equals ax squared plus bx plus c form, is going to be given by a formula, negative of b divided by 2a, where the b and the a come from the numeric coefficients of the x and the x squared respectively. And then the y value of the vertex comes from the function's value at the x coordinate of the vertex. In the vertex form, we can simply read the h and the k right off of the form. The nice thing about this form is that it is so simple to find the vertex. However, we must note that in the vertex form, you must have it written as minus h in order to read the h value, and we must have it written as plus k in order to read off the k value. Should this be plus h, then it would be read as subtract a negative h. So we would have a negative value there. And if this were written as subtract a k, then the k value would be a negative number. Now, the next thing that we need to know is that we have something called a line of symmetry. The parabola is a type of graph that is symmetric to a central line, and that central line goes right through the vertex. And that line of symmetry is going to have an x equals line to it, and that x is equal to the vertex's x coordinates. So if we had it in standard form, we'd be finding that as minus b all over 2a, or if in the vertex form, we would have h. So standard form, this is what it would look like. In the vertex form, we would have the h. So the next thing that we need to know is how to put all these things together. So I had started an example in my class, and we had gone through the following example where we're going to graph the quadratic equation from its vertex form by graphing the vertex, the y-intercepts, the x-intercepts, and symmetric points. So the first thing that we need to start off with is what is our vertex. So I'm going to highlight in yellow what our vertex is looking like. So we see we have x minus and then the h, and then plus whatever the k is. So my vertex is going to be this 1, 3, and that's what I'm going to graph below. So my vertex, I'm going to go over here to x equals 1 and up to y equals 3, just using each of the blue lines to give me each of the blue lines to be 1 unit on this coordinate system that I've drawn down here, and I'm going to put that as 1, 3. Now the next thing that I've done is I have solved to find the x-intercept. So finding the x-intercept, recall, is letting y equals 0. So I've let y equals 0, and I've solved this equation by adding the opposite of this term here to both sides. So now I have x minus 1 quantity squared is equal to 3. And then I'm going to take the square root of both sides. So the square root of the left side gives me x minus 1. And the square root of the right side is going to give me a positive or negative because a square root has both a principal and a secondary root, so the square root of 3. And then I'm going to add 1 to both sides of the equation, so I'm going to get x is equal to 1 plus or minus 3. Now, what this plus or minus means is that I have a root and a solution, 1 plus this square root of 3, and I have a second solution, 1 minus that square root of 3. So those are my two solutions. So my parabola is going to have two x-intercepts because when it comes down this way, because we already know it's a downward facing parabola, right? This is a negative out here. So that means it's going to be one of these, but it's going to have two x-intercepts, one over here and one over here. So now I'm going to go ahead and graph these. Now I have shown you that negative 1, or 1 minus the square root of 3 is approximately negative 0.7, and 1 plus the square root of 3 is approximately 1.7. So I'm just going to say, okay, well here's about a half, and so I'm going to go just a little bit beyond that, and that's where I'm going to put my point there. And then I'm going to go over here to 1 and almost over to 2, and so I'm going to put my second point right there. And so now this will be this point right here, and this one will be that point right there. Then the next thing I need to do is I want to find my y-intercept. So my y-intercept, I'm going to let x equal 0. So I plug x in here. Now remember that this is not going to be like finding the y-intercept for a linear equation, or even for finding the y-intercept of a line or of a parabola, our second degree quadratic equation, where we have the standard form. So we have to put it in, and we actually have to do a little bit of work here. So 0 minus 1 is a negative 1, and when you square a negative 1, that's a negative 1 times a negative 1, and that's going to give you a positive 1, but then we still have the negative, so it's the opposite of a positive 1, and then plus the 3, so 3 plus a negative 1, which gives us a negative 2. Or not a negative 2, sorry, a positive 2. So now I'm going to go ahead and I'm going to plot that. So my y-intercept is right here. So now that I have my y-intercept, what I need is a fifth point to graph this parabola. So my fifth point is going to be a point that is symmetric to this y-intercept. So what I have to do is I have to draw in my axis of symmetry. So my axis of symmetry is this line right here, goes through the vertex, and this axis of symmetry is this line x is equal to 1. So what I need to know is how far is it from this axis of symmetry, right here, over to this point here. So I can see that that's 1 unit over. So I'm going to have to do the same this way, go 1 unit to the right, and that's going to land me at the symmetric point. And that symmetric point, I'm just going to put a dot here for right now, and then we're just going to label that point just like we would if we were just plotting a point and having to label it. So we have that our x is equal to 1, and our y, we know, is on the same plane, so it would be equal to 2. And so there we are. Now I'm going to, in black, go ahead and draw in my parabola. So I'm going to go from the vertex down through these points here, and then from the vertex, oops, that one got misplaced. That was supposed to be over here. 1 and 0.7, not 0.7. I think I got off when my pen started fussing around with me. And so we have through this point here, and through the pink point and then down like that. And there is our parabola. So we've now succeeded in graphing the parabola based on 5 points. We start with point number 1, our vertex. Points 2 and 3 are x-intercepts. Point 4 our y-intercept. And point 5 our symmetric point to the y-intercept. And that creates 5 points. All right, that wraps up that example. Next video I'm going to be talking about translations of quadratic functions.